differs between those two different loggers.
Yeah, and I think it's important to note that resolution only gets you so far. If your resolution is 1,000 times better than your accuracy, then what you're going to be seeing is a lot of noise, which in some cases actually can be more confusing to see some bits jumping up and down when there's really nothing happening, or maybe there is something happening, but your logger isn't necessarily responding because it's not accurate enough. So your resolution and let's see, next question is, do onset loggers have logarithmic sampling options? The straight answer is that no, we do not have a pre-programmed logarithmic sampling. In our loggers, what we've chosen to do is we have user-selectable intervals, so that if you want to emulate logarithmic sampling, you can. You can set up to 8 different logging intervals, and you can set an arbitrary number of data points. So, for example, if you wanted to log for 5 minutes at once a second, you could set up 500 data points at a 1-second interval, and then shift to another 500 data points at a 5-second interval, and another 500 at a 10-second interval, or whatever you like. I think it's actually handy to have it in this mode because you can actually set up a slow logging rate prior to a pump down test when you actually start the test, and you can see what's going on, and then log at a fast rate when the pump starts or when the pump stops, or sort of see what happened before to make sure that everything was really at equilibrium before your test started. But you do have to set that up the very first time.
That's right.
Another question is, can I import barometric files from a different manufacturer?
Yeah, it's possible to do that. Of course, it depends on the output structure of that other manufacturer. In the case of Onset product, we can import a text file from any source that has barometric data, whether it be a weather station or another manufacturer's logger, as long as that other manufacturer can export its data in a text format.
The next question is, actually, I'm not quite sure I understand this question. Somebody asked, what's the difference between a vented and a non-vented logger?
Well, we pretty much covered that earlier in the talk. Evidently, this is from a late arrival. Perhaps you can download the presentation, but primarily it's the non-vented logger is referenced against the vacuum. The vented logger is referenced against barometric pressure, which is brought to the logger by way of a vent tube.
Okay. Next question, somebody asked for, please give an example of how to get a reference. Does this mean using a tape measure and measuring down to the sensor? Well, I'll start on that one. How to give a reference is a little bit variable. Let's assume that you're in a well. What would typically happen is that that well would be in a surveyed location at a known altitude. And yes, in that case, you'd use essentially a tape measure. They have both chalk lines and
electronic
ones that when they beep when they hit the water level. Right. And what you'd be doing is measuring from the top of the well casing to the water surface. So you don't actually have to measure down to the pressure sensor itself. That's where the software will take that pressure, when we talk about converting from pressure to water level, by providing that reference level, you're essentially zeroing the logger at that level. So in this example, if the water level were 20 feet down and your logger was 25 feet down, it would automatically adjust that so that your starting level would be at 20 feet below.
That's right. What's really nice about the feature is it allows you the reference measuring. If you're trying to measure from the bottom of the screen to the top, if you're trying to measure from a bridge abutment down to the surface, whatever you decide you're trying to measure as an output, that's your reference measurement. And then the logger output data will all be referenced to that point.
Now, at the risk of going too far on this question, it does get more complicated once you get out of wells. For example, if you're doing a tidal study, Typically, you'd want to reference things relative to mean sea level, and deciding what is mean sea level is an art that's well beyond this discussion. But you basically are going to be measuring the surface of whatever water you're interested in relative to something, whether it's the top of a dock, whether it's a surveying benchmark, whether it's the top of your well casing. Next question. Do you have a source for temperature and barometric pressure data that works with your software?
So we really have numerous sources. We have barometric loggers, which is the water level logger itself, or we have weather system data. We sell weather systems, and you can also import text files from any source into our software. And it does not have to be at the same sample rate as the water level logger, because our software does interpolation as well.
Okay. Next question is, are there elevational limitations above sea level for your logger? Yes, there are. The calibrated range on our logger is 10 psi to, or on our lowest range logger is 10 psi.
Right. They actually all start at 10 psi.
Yeah, and 10 psi roughly correlates to about 10,000 feet of altitude. So at sea level, you're at about 15 psi. At 10,000 feet, you're at 10 psi. So that's sort of our minimum or our maximum altitude, minimum pressure that you can expect to accurately barometrically compensate your data files with using our own logger. So that essentially puts a limitation at 10,000 feet. Outside of that, you're outside of calibrated range of the logger, where the accuracy is not specified.
It starts to degrade, but it still will operate.
Okay. And let's see, we're going to have one more question, then we're going to wrap it up, I think. One question is it possible to bury the depth logger in the stream bed in order to develop a rating curve? And as sort of a follow-up to this, if buried in a stream bed, will the position of sediment influence the pressure recording? The answer is probably yes and yes, but you might not want to bury the logger directly. What we've seen some people do is they'll actually make themselves a housing for the logger and take a piece of PVC, wrap it in screening, like a sort of heavy-duty wire screening, to try to make sure that the pressure sensor, the business end of this thing, doesn't get impacted with sand, rocks, and debris. You want it. It is a pressure sensor. The ceramic sensor is a little bit more durable than stainless steel, but still not a good idea to have rocks or sand, directly pressing into the pressure sensor. So some people have built little PVC sort of pipe bomb type things. Other people have done them out of steel. We actually had some different application, but down in the hurricane season last year in Louisiana, they built steel housings to protect our loggers, which were quite successful. Okay, so I'm going to wrap this up here. We do have a few more questions, which we will answer by email. Thank you very much for participating. This webinar is going to be available for replay on our website if you want to play through it again. And the slides will be available there also, so you can relive the moment. You can also send myself or Richard email, and we'll be happy to answer any specific questions that you have. And thank you very much for participating.
Thanks for your time. Glad to talk to you.